Hello guys, I am Rahel Yulianti and my friend Ananda Fairuz and Nurul Islamia. We want to explain you about finite state machine and behavior trees. Okay, I will explain about finite state machine. For introduction, a finite state machine is a computation model that can be used to simulate sequential logic, or in other words, to represent and control execution flow. Finite state machine can be used to model problems in many fields, including mathematics, artificial intelligence, games, or linguistics. The definition of finite state machine is a model of computation based on a hypothetical machine made of one or more states. Only one single state of this machine can be active at the same time. It means the machine has to transition from one state to another and to perform different actions. A finite state machine is any device storing two states of something at a given time. The state will change based on input, providing the resulting output for the implement change. Okay, next, this is the important point. Here are the following. The first is we have a fixed set of state that machine can be in, and the second is the machine can only be one state at a time, and the third is a sequence of input is sent to the machine, and the fourth is every state has a set of transition and every transition is associated with an input and pointing to a state. Okay, this is the real world example. The first is coin operated turnstile. The state is lock and unlock. The transition point of coin in the slot will unlock the turnstile. Pushing the arm of the unlocked turnstile will let the customer pass and lock the turnstile again. The second is traffic light. The state is red, yellow, and green. The transition is after a given time, red will change to green, green to yellow, and yellow to red. Okay, in finite state machine there is a stack-based finite state machine. We could go a little further. We could use a stack-based finite state machine. With our previous solution, we have no concept of history. We know our current state, but we can go back to the previous state. To solve this problem, we could use a stack. We store elements in LIFO style, last in first out, to save our different state. That means the current state in the one of the top of the stack. Then we want to transition to a new state. We push that new state onto the stack and this state becomes a current state. When we are done, we pop the state and the previous state becomes a current state. Of course, it is our responsibility to manage which state we want in the stack and which we want to discard. Okay. The conclusion from finite state machine is a model of computation based on hypothetical machine made of one or more states, and only one single state of this machine can be active at the same time. Okay, next presentation will presenting by Nurul Islamia. Okay, I will explain about the behavior trees. First definition. A behavior tree is a mathematical model that details the plan of execution of a predefined set of tasks. If you have a finite set of tasks, then a behavior tree is where you specify how the program switches from one task to another. Behavior trees were initially used to develop video games but are now widely used in robotics, computer science, and artificial intelligence. With behavior trees, complex tasks such as catching Pac-Man are made possible through a series of simple tasks. In Pac-Man, these tasks include determining the location of pills and fruits. Next, the second is application of behavior trees. Behavior trees in robotics. Behavior trees make robotic application more efficient and productive. Imagine a robot assigned to pick up cans from the floor to put them on a specific shelf. Without employing a behavior tree, the robot would go on its route, regardless of event. For example, the robot would not stop even when it drops a can or when a person is directly in its path. As a result, it would end up not doing its task efficiently. When the same robot is created using a behavior tree, it can program it to stop when something blocks its path. It can further be taught to go back to its original position or alert a human being when this happens. And next, behavior trees in computer games. As previously mentioned, behavior trees were first used in computer games to control the behavior of non-player characters or game characters the player does not control. In essence, behavior trees provide AI to these characters. Some examples of computer games that use behavior trees are Pac-Man, Halo, Spore, and Bioshock. The third is, how do behavior trees work? Simply put, the goal of behavior trees is to give non-player character AI so they can execute specific action. If you notice a Pac-Man game, the ghosts seem to be drawn to the pills. The ghosts were taught through the behavior tree to defeat Pac-Man by going where the pills are located. Over the years, behavior trees have evolved to keep up with industry developments. At present, behavior trees are mostly event-driven, which means that non-player characters and programs can already be programmed to reach to events. The fourth is behavior tree limitation. Creating robots, applications, and games using behavior trees make them a lot better in terms of efficiency and performance. Still, behavior trees have limitations. One of them is the need for tools when navigating through large behavior trees. The most significant restriction is that it does not teach a program to make better decisions. Since the decision-making process is hard-coded into the tree, it does not teach the characters or robots how the decisions are made. Behavior trees have greatly improved the way robots, video games, and computer programs are developed. Its evolution toward becoming event-driven also helped improve efficiency and made technology products more intelligent. But like any technology, it has challenges and limitations. The demand for more features and functionality could propel the further evolution of behavior trees. Okay, the next presentation presented by Anjab.
Okay, my name is Anjab. I will explain the advantages and disadvantages of finite state machine (FSM) versus behavioral trees. The main advantages of finite state machines are increased modularity. It is possible to separate the tasks in subtasks. However, the subtasks often still depend on each other through state-dependent transition. Behavior inheritance. The finite state machine allows so-called behavior inheritance. Behavior inheritance allows substates to inherit behavior from the superstates. For example, in the HFSM depicted in figure. While in the substats inside used handgun, the character holds the weapon using one hand, whereas while in the substats in the use revolver, the character holds the weapon using two hands. Thus, there is no need for the substats to specify this property. Instead, it is inherited from the superstats. The main disadvantages of finite state machine are maintainability. Adding or removing state is still hard. A long sequence of action with the possibility of going back in the sequence. and they re-execute a task that was undone by external agents, e.g. the environment, still requires a full connected subgroup. Medially create hierarchy, although as FSM were conceived as hierarchical version of FSMs, the hierarchy has to be used define and editing such hierarchy can be difficult. The hierarchy resolves some problems, but reactive FSM still result in some subgroup being fully connected with many possible transitions. Okay, next the advantage of behavior trees are. So the advantage is flexible in use in program writing when combined with other methods. The second is the behavior tree is said to be strong because it's reactive or to AI built in various conditions. And third, easy to change because it is modular. Change can be made to the visual without having change the transition session like FSM. So the main disadvantages of behavior trees are, however, the major challenge with behavior trees is that even though the technique will better organize behaviors, it does not provide a model for improving decision making. The decision making is locked to the conditional nodes without the specifying how decisions are made to invoke different substrates. Thank you from me. Assalamualaikum warahmatullahi wabarakatuh.